Hi everyone, thanks for being here. Today we are representing our project dyspepsia related adverse events analysis using PySpark. My name is Gongchen.
My name is 东健葛.
My name is 岳阳杜.
My name is 泽义成.
My name is Yu Xuanliang.
Okay, we use the large dataset from FIRS, the FDA Adverse Event Reporting System. The dataset includes about 1.8 million records, each representing an adverse event case. Because the dataset is so large and detailed, we use the PySpark for scalable data processing. Our project is guided by four main research questions. The first one is which dyspepsia drugs have the largest numbers of adverse event reports? And the second is, are there gender differences in adverse events for different active ingredients? The third is there a dose severity relationship? And fourth is, can we use a machine learning model to predict the affected system organ class from drug plus gender? Okay, I will hand it over to Dongjiange.
Okay, now let me describe the dataset and how we proceeded. Fields reports include many standardized fields. A few important examples include the drug name, the reported drug, and the prod AI, which is the active ingredient, and PT was the reaction term, and the reaction subname, which is a broader organ system affected. And also we have dose amount, which is a drug dosage taken, and drug sequence, which is the order of drugs when multiple medications were involved. Also, we have other variables to fit the model. Because the dataset is huge, PySpark was the best tool for the job. And our workflow included loading the dataset and inspecting its structure, finding the highest reporting drugs, and cleaning and filtering important fields, analyzing gender differences using the prod AI and gender variables. Also, we created a prod AI cross-gender interaction variable and building a random forest model to predict the reaction subname. Exploring dose severity relationships using dose amount and outcome code. And the last one is studying multiple drugs using through drug sequence. And this workflow allow us to explore the data through using both SQL and machine learning.
Okay, so let me introduce our key findings. So I'll present our first major finding, which is the highest reporting drugs. Using the drug name variable, which identifies the medication in each report, we grouped and counted records. The drugs with the most dyspepsia-related reports were Zantac, over 630,000 cases, and additional ranitidine entries around 370,000. The rest two are pantoprazole, almost 90,000, and metoclopramide, around 80,000, which shows that ranitidine-related drugs clearly dominate the dataset, which fits their well-known historical safety concerns. And here's our top 5 reactions by drug cross-gender. What we observed is that the top reactions are highly concentrated in neurological disorders, which these reactions also have different frequencies for males and females, which supports our broader finding that drug safety profiles vary significantly by gender. Now, we also analyzed the gender variables, which is M or F, for each prod AI, which stands for active ingredient. We found clear patterns. Omeprazole and other PPIs like esomeprazole and pantoprazole appear significantly more often in female reports. Ranitidine hydrochloride showed higher proportions in male cases. Some drug ingredients show gender differences of 10% or more. This suggests meaningful demographic differences which could reflect biology, prescription habits, or reporting patterns. Now let me hand it over to Zichen.
Okay, now let me walk through our machine learning component. We use Spark MLlib to train a random forest classifier to predict the React shortnet, which is the system's organ class of each adverse reaction. Our feature was the uh, our feature was the product AI, the active ingredient, and the genders, the patient's gender. The product AI gender is interaction terms combined the two. We first convert these categorical variables using the strength indexer and one hot encoder, and assembles that into a vector using a vector assembler. And our pipeline was strength indexer to one hot encoder to a vector assembler to random forest classifiers. And for the performance is our models achieved 81 accuracies. And given the simplicity of our feature set, no laboratory values, no comorbidities, and no age groups. This itself is the surprising strong, the feature's importance. We examine the feature's importance and found the prod AI contributes the most to the production, and the prod AI genders interaction also rank highly. And the standalone gender variables have a lower importance, but still help when combined with the job information. This shows that both job type and gender relate to different influence. What type of the adverse event occurs?
Okay, so I'll finish up by summarizing our final analysis and the conclusions. So the first one will be the dose severity relations and analysis. So we're using the dose AMT as we reported as our dosage and our out COD as our severity code. And then we choose to group them those doses into our four preset ranges. So for example, like less than 10 milligrams, 10 to 50, 50 to 100, and 100 plus. So the severe outcomes included the HONDE, which is referring to the hospitalizations as well as the death. And our record and result it shows that the doses is with less than 10 milligrams will be having approximately 29%, and 50 to 100 milligrams will have approximately 2%, with 100 plus milligram with over 12%, which is meaning that higher doses were highly associated with those significant higher rates of severe outcomes. Okay, second will be our multi-drug combination risk. So we are using our drug sequence to measure how many different drugs were actually involved in our cases. And as the numbers show here of our drugs increases, the rate of severe outcomes has also raised, as we can see from the graph. So one drug with all gathering together will be having 6% of a severe rate, and 4 for 10%, and 12 for 15%, and as you can see, 20 plus for approximately 18%. And this information and resulted showing us and confirming that the polypharmacy can be increases the safety risk. And as our key findings and our conclusions across this project, that we have learning that ranitidines and PBLS can dominate the dyspepsias and its related adverse impact, adverse events, I'm sorry, in which there are a clear gender differences in adverse reaction patterns, plus a higher doses and more drugs will increases the chance of severe outcomes. And a simple random forest model can help us in predicting our rack stock name with 81% of accuracy, and that's pretty high. And the PySpark that we are using in this project really help us a lot in handling our large FARS dyspepsia data set and break it down and helping us into those patterns so we could quickly just to interpret and also to conducting our research. Thank you for listening.